sense. And then there's some actual like kind of difficult concepts too. So let's just start here. What's the derivative of any constant? Well, two ways to think about it. Let's say I had y equals 9. That's a constant, right? Derivative is just slope. All the derivative is. So what kind of line is that? Don't say straight. What kind of line is it? That's your goal. Horizontal. What's the slope of any horizontal line? 0. So what's the derivative of that? 0. Or, if you prefer algebra, couldn't I write 9 as 9x to the 0? You guys good like that? Because what's x to the 0? It's 1. So this is the same value. Now I can use my power rule. So take the 0, bring it down, multiply by 9, what do you get? 0. Reduce the power by 1, but it's not going to matter anymore because what's 0 times anything is 0. So the derivative of any constant is 0. You got to think about it two ways. Like that's a horizontal line, so the slope is 0, or kind of work your way around the power rule there. You can do the same thing with c. It's not just a constant in front. So let's say I had like y equals 5x. Well, what does the derivative represent? Starts with an S. Slope. That's a line with a slope of 1. 5. So if the slope is 5, what's the derivative? It's 5. Or, if you prefer, this is like 5x to the first. So following the rule, you bring down the 1, multiply by the 5, which is 5. You got your x, and then reduce the power by 1. But then what's anything to the 0 power? 1. So you get 5 either way, whether you think about it like kind of graphically or algebraically. So the derivative of a constant times u would be the constant. And then some difference, I'm not even going to write it out because no one really thinks about it the way it's written there. All it means is if I have like we just did one of them before, actually. So I gave you that, right? And I said take the horizontal tangent line one, right? Yeah. So you got to take the derivative until it equals 0. How many of you got to that for the derivative? So that's the rule so we technically had an But the rule that this is trying to show you, one of the rules in this lesson, is if you have a derivative of like two things being added together, you can take the derivative of one and then add the derivative of the next. It's kind of common sense. If I have y equals x squared plus 2x minus 4. It just says you can take the derivative of each one at a time. So what's the derivative of x squared? 2x. That'd be positive 2. And then that would just be 0, right? So that's like the rule. You can take the derivative one at a time. That's all that thing is trying to say. So try 1 and 2. Those are a little tougher derivatives. Negative exponents and radicals and stuff there. Then we'll get into better stuff. This is C. Anyway. So I would be rewriting these first, and then taking the derivative. What I mean by that is I would write this as 2x squared minus 5x to the negative 1 plus 6, because I don't know how to take the derivative of a fraction. And I would rewrite this as that's not the derivative, right? That's just like rewriting it. So let me go through. It's a good review of like power rule, algebra, just rearranging things. So 2x squared is pretty straightforward. That's just going to be a derivative of 4x. 5 over x, I don't have like a fraction or a quotient rule. So 5 over x, I'm going to bring that x up and write it as 5x to the negative first. And then I can use my power rule. So negative 1 times the negative in front is positive 5. Reduce the power by 1. So if you're subtracting 1 from negative 1, you get negative 2. And what's the derivative of the constant? What's the derivative of 6? Or any number is 0. So that's your derivative for number 1. Question on 1. Yeah. That's not wrong, certainly. So you can do that. I'm not going to, at this point, I'm going to say, like, don't worry about it. Either are fine. On the test at some point, I might change that. But number 2, so same idea. That's 8 times the square root of x, which is 8x to the 1/2. This part, people screw up. So that's x to the 6th over 3. So there's really like a 1 there. And then that fraction you can pull out and say, okay, that's 1/3 times the x to the 6th. So the rewrite is the key there. So that's going to be 4x to the negative 1/2, and then minus 2x to the 5th. And then that's just a giant constant, isn't it? Pi is 3.14, and the 5th is a little bigger. Times 2 is double that, but it's still a number, so what's the derivative of a number? It's just 0. So those are your 2 derivatives for 1 and 2.
4 over the square root of x.
So for your next test, so when I was at U of M, I had to do this. I took Calc 1, and there's this test they called the Gateway. It didn't Calc 2 also. So you take the Calc 1 class, but then at some point in the year, you have to go to the Freeze building, it was at U of M, tell them you're here for the Calc 1 Gateway, and take the test. And if you didn't pass that, you never got a grade in the class. You just failed the class. So this was like a requirement. Like you have to pass the class, but you have to pass this test to prove to us that you know what you're doing. I'm not doing that. I'm not saying if you don't pass this test, you don't pass the class. But what I'm going to do is similar. So it's going to be a 10 question. Your next test will be 10 questions. They'll all be about derivatives and stuff we're going to do with derivatives. But if you get any one part of that wrong, so like some people here might have said, I don't know, put a +2 or something, or maybe you put a -3 there. There's no partial credit. So there's 10 questions, you get no partial credit, and I'll be honest with you, the first time people take it, the class average is probably like 50. But you get 3 tries, and I'll take your best one. So it's very common, a lot of people get like 50, 60, and then they're like, oh crap, they started about out, and I get like 90. What? Good question. The corrections is you get 3 tries. Like that's 2 retakes, really, right? So like the downside is I'm not going to give partial credit. The upside is you get 3 attempts. But one of the reasons I do it is because it kind of mirrors like another reason I do it is because people will, I guess just one second. People will do something like this, and I'm not saying it's wrong, like I'm guilty of it too. But you'll put like a -3 there, and then I'll go through it and you'll get it wrong. And you'll be like, oh, that was stupid. But like, it's still a mistake. So on a test, like everyone makes the mistakes, but I'm trying to get you to, on a test, really take your time and slow down and be thorough and check those little things a lot. Yeah, so we'll take it one day. You'll turn it in. I will maybe be able to grade them before you leave the class. I think I get back to it. And then that night, I'll sit down and do it, and like record what I'm doing, so you can watch the video and once you missed, kind of see what to do from there. Then we'll just do it again the next time. I'll make another video. We'll do it again the next time. Yeah. So it's the same, like similar types, but different numbers, different setups. Like I have my program, I can say like, give me a problem that is asking for the derivative of a trig function, and it'll give me one, and then I'll just ask you for it's the same.
Alright. So it's gonna be just on like 2.5 to like wherever.
It's gonna be an algebra 2. So it's not for a while.
And then for the test, are you like a lot of
For this test, no, actually. Because there's things you have to memorize for it. There's derivatives you have to memorize. So you don't get a cheat sheet on this.
40%?
Nothing.
Is it only out of 10? 10 points?
Well, it'll be 100. I'll scale it to 100. Usually I can have all or most of them graded before you leave. So you know what you got. You'll be done if you will. Should be one of the first ones done. I'll grade it. You'll be fine. If you're staying like until the close to the end of the hour, I'll stay after school and grade whatever you want. If you have to leave right away, you might not know, but you probably will. You guys don't ask anywhere close this many questions on like the actual freaking math.
Well, because we're not terrified about that stuff.
Antonio.
Wait, are you gonna at least give us like a practice test?
You want like a practice gateway?
Like like the one that you did last time, like with the same questions.
Yeah.
So what else? Sort of. I'll give you like, here's a topic that we did. Here are 3 or 4 questions that are examples of that topic. Here's the next topic we did. Here's 3 or 4 examples of that topic. And I just like choose from those. So yeah, you'll have a review. It's not going to be straightforward like here's the 10 questions, but you'll know the topic.
Alright.
I didn't realize it was so scary.
Yeah,
It's
it's 100 points.
Nobody does that.
Yeah, but it's like, it's
Yeah,
10
but
questions, no cheat sheet.
Yeah, 10 questions on cheat sheets.
Okay.
Actually, it's like a trouble of thumbs.
Well,
We're getting
that's
too long. The board's gonna write up.
Yeah.
Let's move on to the math. So we can pass the gateway. Horizontal tangent lines we have done. We did one on the warm up. So if I can see the graph, I can kind of tell it's going to be there and there. So it's it's probably like -1 and 2 or something. But I want to find where it is actually. So horizontal tangent lines. What do I know is true if there's a horizontal tangent line? Slope is 0, which means don't say no slope. No slope is actually like vertical. Slope is 0, which means algebraically what do I do? What's it? Is that that? That's the derivative equals to. Derivative tells us slope. So that's slope. We want it to equal 0 because that's horizontal. Do what so quickly? 4 times 2?
Yeah.
That's what you're asking. So you bring it, it's just 4 times 2. Sorry, did I go too fast? It's not, okay. What? What's up? Horiz. Horizontal.
Wait, the x, the 8x plus 7 is just the derivative.
That's the derivative. I'm not done yet. Because that's like the equation I have to solve, but I still have to solve it, right? So that would end up being x equals negative 7/8. Question on 3. So like there will be one on your gateway that says find any horizontal tangent line. The derivative probably won't be that simple. So that's what happens. Like, the horizontal tangent line is just going to stay, and then we'll get into other ways to take derivatives.
Will there be a graph for it?
I don't. No, there would not be. All right, normalize. That's not a number. Okay. So at x equals 3, x equals 3 is like around there. We have gone through finding the tangent line. You guys stop talking, please. So that's the tangent line, right? And that's what we've done. The normal line is perpendicular to that. So we'll go through the same point. It'd be like a right angle there. And so that's the equation we're looking for here. So just kind of think to yourself, looking at the graph, should my slope be positive or negative of the normal line? Should be negative because that's sloping down. If you have a slope of -3/4, what's the slope of something perpendicular to that? perpendicular would be e over a. Okay? Okay, so then I'm going to do this problem here. So y equals blank times x minus blank plus blank. Why did I put that there? The equation of line. It's on the equation of line, right? What goes here is always the x value. So they're just telling me that's 3. What goes here is the y value. You get the y value by plugging into the original. 27 minus 36 plus 3 plus 3. So I believe that is negative 3. With me? Now I gotta plug in to find the slope. So my derivative is 3x squared minus 8x plus 1. And that's just taking like one term at a time. And the 1 comes from the x. That is my derivative. If I plug 3 into that, what will it tell me? Slope of what? The tangent line. So then what am I going to have to do with that? Flip it over and change the sign. So I'm going to plug in 3. So 3 times 3 squared minus 8 times 3 plus 1. So 27 minus 24 is 3 plus 1 is 4. That's the slope of the tangent line. That's this guy. That makes sense. Like, that should be 4. It's going up pretty steep, right? If they ask me for the equation of the tangent line, I would put 4 there and it'd be done. But they're asking for the normal line. So I put a negative 1/4 there, and I'm done. And that's the slope of that blue. And I took a negative reciprocal of that slope. Right or what? I thought you said that. Should I have heard that? Probably not. Why do you guys say things out loud? It's weird. I don't care. You just said you care. Okay. We're gonna split this. No, we're not. We're gonna keep going. Yeah, we're gonna stop. Sorry. So you got homework on 2.6, but we didn't do the whole unit. So let me tell you which ones. Yeah, you go 1 to 16. Wait. I was looking at the rest. Yeah, 1 to 16. Tomorrow we're gonna finish 2.6 and then actually do 2.4. We're gonna go back and pick up 2.4. That's
I'll try and watch it, but there's a good chance we'll get it into the finals, so.
I hope you do. Do you mean like your flight?